Hi everyone. Today we're going to be completing our notes on quadratic functions in standard form. So to begin, I want to take a look at this warm-up here. Here I have four graphs and I want to consider the x and y intercepts. Recall that the x-intercept is where the graph crosses the x-axis, and likewise the y-intercept is where the graph crosses the y-axis. So the first one is done for us. This graph crosses the x-axis at 4, 0 and crosses the y-axis at 0, -2. For the second graph, this crosses the x-axis in two places, first at -3, 0 and second at 4, 0. It crosses the y-axis at 0, -3. Remember, these are ordered pairs. Next, for the third graph, this crosses the x-axis at 1, 0 and then crosses the y-axis at 0, 2. And then finally, for the last one, this crosses the x-axis at -2, 0 and then crosses the y-axis at 0, -4. So take a moment and look at the x-intercepts and the y-intercepts and see what they all have in common. Go ahead and write your answer below. I notice that all the x-intercepts have a y-coordinate of 0. And likewise, all of the y-intercepts have an x-coordinate of 0. Okay? And that's going to be true for all x and y intercepts. The x-intercept is where y equals 0, and the y-intercept is where x equals 0. In section 9.2, we learned how to solve a quadratic equation by factoring. And this was when we had that the equation was equal to 0. And so when we would solve this, we could use the zero product property to find solutions for x. Now, if we have an equation that is equal to y, what we can do is we can set y equal to 0, and then suddenly our equation is equal to 0. And we can solve, similarly, using the zero product property to get the x-intercepts. Okay, so when we solve for y equals 0, or when we plug in y equals 0, and we solve for x, we're going to get the x-intercepts, and we're also going to get solutions to that equation for y equals 0. Okay? Now, we're only going to be looking at where there are two x-intercepts. Okay, so where the graph crosses the x-axis twice. We're not going to spend as much time looking at where it crosses the x-axis once or not at all. Let's take a look on the next page. We're going to remember the axis of symmetry. The axis of symmetry is the vertical line for which the function, the graph, is symmetrical. So it's going to divide the graph into two equal halves. So for graph A, if I sketch on a vertical line right here, then I see that I divide the graph into two equal parts. This axis of symmetry has the equation x is equal to -1. For graph B, I can sketch on a vertical line right here at x equals -3. And then finally, the last one's a little bit tricky. You can sketch in a vertical line here. The axis of symmetry is x equals -1/2. All right. Now we can go ahead and find the x-intercepts algebraically. Remember, the x-intercept is where y equals 0. So we're going to plug in 0 for y and then solve for x. So plugging in 0 for y into A, we get the equation 0 equals negative the quantity x plus 2 times the quantity x plus 4. To get rid of that negative out in front, I'm going to divide both sides by -1. And we get 0 is equal to the quantity x plus 2 times the quantity x plus 4. Using the zero product property, I can set each factor equal to 0. So we get the two equations, x plus 2 equals 0 and x plus 4 equals 0. Solving both of those equations, I get solutions x equals -2 or x is equal to -4. So taking a look at our graphs, which one has the corresponding x-intercepts of -2, 0 and -4, 0? The answer is graph B. Let's try 2B. So here, again, we're going to find the x-intercepts by setting y equal to 0 and then solving for x. So let's go ahead and factor the right-hand side of this equation. We're looking for factors of -2 that add to +1 The answer is positive 2 and negative 1. So this factors to the quantity x plus 2 times the quantity x minus 1. Using the zero product property, we can set each factor equal to 0. So we get x plus 2 equals 0, or x minus 1 equals 0. And we get solutions for x equals negative 2, or x equals 1. So these x-intercepts of negative 2, 0 and 1, 0 correspond with graph C. And finally, you could probably figure this out using process of elimination. But let's go ahead and solve for it algebraically. To find the x-intercept, we set y equal to 0. And then let's go ahead and factor. So this is set equal to 0. So this quadratic expression has a GCF of 3x. So factoring, we get x plus 2. So 3x times the quantity x plus 2. Using the zero product property, we can set each factor equal to 0. So I get 3x is equal to 0, or x plus 2 equals 0. Solving the first equation, we get x is equal to 0, or the second equation, we get x is equal to negative 2. Now the graph that corresponds with this, yes, you guessed it, is graph A. Okay, so we can find the x-intercepts algebraically by setting y equal to 0 and then solving for x. But how can we find the vertex? We know that we can find the vertex by using the axis of symmetry. It's also the maximum or minimum of the graph, the highest or lowest point of the graph. So we can confirm this by looking at the graphs above. So the vertex in graph A is going to be down here, in graph B is up here, and in graph C down here. Okay? Well, we can also find it algebraically. One way that we're going to do this is by using the axis of symmetry. We're going to find the x-intercepts and plot them, and then we're going to draw in the axis of symmetry. We're going to use that x value to plug into the original equation to find the y value of the vertex. So let's go ahead and start with finding the x-intercepts. So using this equation, y equals the quantity x minus 1 times the quantity x plus 3, we're going to set y equal to 0. So we have 0 equals the quantity x minus 1 times the quantity x plus 3. Zero product property, we can set each factor equal to 0. And solving both of those equations, we get x is equal to 1, or x is equal to negative 3. So let's go ahead and plot those x-intercepts. We have 1 at 1, 0, and 1 at negative 3, 0. Okay. So now we know that the axis of symmetry is exactly in the middle of those 2 points. So right in the middle of that, our axis of symmetry is going to have the equation x is equal to negative 1. So let's go ahead and sketch that in. So our axis of symmetry is x is equal to negative 1. Now let's go ahead and plug in that x value into the original equation. So y is equal to, now plugging in negative 1 for x, we get negative 1 minus 1 times negative 1 plus 3. And solving for y, we get y is equal to negative 2 times positive 2, or y is equal to negative 4. So the coordinates for our vertex is x equals negative 1, y equals negative 4. So we have negative 1, negative 4 are the coordinates for our vertex. So we can go ahead and plot that point right here. We can use those 3 points to sketch the graph of this quadratic equation. All right. So in summary, find the x-intercepts. The axis of symmetry will be exactly in the middle of those 2 x-intercepts. Use that x value of the axis of symmetry and plug that into your original equation to find the y value of your vertex. Plot the points, connect the dots, you got a graph. All right, the other method we can use to find the vertex is to find the middle value between the intercepts algebraically. So here we did it with a graph, right? It's exactly in the middle of our x-intercepts. You can also do that algebraically by taking the average of your x-intercepts. So if you recall, taking the average, you can just add up all of the numbers and divide by the number of numbers that you have. So let's go ahead and find the vertex of this equation, starting with the x-intercepts. So the x-intercept, we're going to plug in 0 for y. So 0 is equal to x squared minus 8x plus 7. And then we're going to go ahead and solve for x. So factoring this expression here, we get 0 is equal to factors of 7 that add to -8. We get x minus 7 and x minus 1. Using the zero product property, we can set each factor equal to 0. So x minus 7 equals 0, or x minus 1 equals 0, gives us solutions x equals 7 or x equals 1. Okay, so this is step 1, the x-intercepts. To find the x value of our vertex, we're going to take the average of our x-intercepts. So we're going to take our x-intercepts, 7 and 1, we're going to add them and divide by 2. So the x value of our vertex is equal to the quantity 7 plus 1 divided by 2. So we get 8 divided by 2, or 4. And then finally, step 3, we can plug in 4, our x value, into the original equation to find the y value. So we get y is equal to 4 squared minus 8 times 4 plus 7. And that comes from our original equation. We're plugging in 4 for x. Remember, anytime you plug in anything, you're going to use parentheses. So y is equal to 4 squared is 16. 8 times 4 is 32, so minus 32, and then plus 7. So y is equal to negative 9. So then the coordinates for our vertex is 4, negative 9, and let's go ahead and write that. Positive 4 and negative 9. Okay. So in summary, we find the x-intercepts first for both of these processes. In the first process, we find the axis of symmetry is right in the middle of the x-intercepts to find our x value. In the second, we take the average of the x-intercepts to find the x-coordinate of our vertex. And in both of these, we plug in our x value of the vertex into the original equation to solve for the y-coordinate of our vertex. Okay, so let's go ahead and practice. So for question 1, graph the parabola y equals the negative times the quantity x minus 7 times the quantity x minus 3. So we're going to find the x-intercepts by setting each factor equal to 0 and solving for x. So x-intercepts set y equal to 0. So negative x minus 7 times the quantity x minus 3. Get rid of that negative out in front by dividing by negative 1. And we get 0 is equal to x minus 7 times the quantity x minus 3. Using the zero product property, we can set each factor equal to 0. So we get solutions x is equal to 7 or x is equal to 3. Okay, so now we can go ahead and plot those points. X is equal to 7 or x equals 3. Step 2, find the vertex. So use the axis of symmetry or just take the average of the two x-intercepts. So you can choose which method you prefer. I'm going to choose the second method, find the average. So the x-coordinate is equal to the average of 7 and 3. So I'm going to take the sum of 7 and 3 and divide by 2. We get 10 divided by 2, which is equal to 5. So the x-coordinates of our vertex is 5. So I can actually go ahead and plug that in there. And then let's go ahead and use that to find our y-coordinate. So back to the original equation, right up here, I'm going to go ahead and plug in 5 for x, and we get y is equal to negative the quantity 5 minus 7 and 5 minus 3. Okay, so y is equal to negative, 5 minus 7 is negative 2, and 5 minus 3 is positive 2. Negative times negative 2 times 2 is equal to positive 4. So the coordinates for my vertex is 5, 4. So now we can go ahead and plot that point, our vertex. So 5, 4 is right here. We can go ahead and graph the parabola. Don't forget to extend your lines and draw those arrowheads. Okay. This parabola opens downward, where the vertex is a maximum. The x-intercepts we found to be 3, 0 and 7, 0. Okay. Now, before we move on to number 2, is there a way that we could have told from the equation whether this function, this parabola, would open up or down? take a look at the equation and see if you can determine from the equation whether it would open up or down. The answer is yes, we can determine from the equation, and it has to do with the leading coefficient. Notice that there's a negative out in front of this entire grouping. This is going to tell us that the parabola is going to open downward. If this was positive, if the leading coefficient was positive, then this would cause the parabola to open upward. All right, let's try another. Let's go ahead and graph the parabola y equals 2x squared minus 4x. Let's find the x-intercepts by setting y equal to 0 and then solving for x. So this is equal to 0. Let's go ahead and factor. This has a GCF of 2x, and so we're left with x minus 2. Using the zero product property, I can set each factor equal to 0. So we have the equations 2x equals 0 or x minus 2 equals 0, which gives us the solutions x equals 0 or x equals 2. So let's go ahead and plot our x-intercepts of 0, 0 and 2, 0 right here. 0, 0 and 2, 0. To find the vertex, I'm going to use the average method again. So we're going to take the average of the x-intercepts to find the x-coordinate of our vertex. So the average of 0 and 2, we take 0 plus 2 divided by 2 is equal to 2 over 2 or 1. So the x-coordinates of our vertex is 1. And then to find our y-coordinate, we plug in 1 for x into the original equation. So we have y is equal to 2 times 1 squared minus 4 times 1, which is equal to 2 times just 1 minus 4, which is equal to negative 2. So the coordinates for our y coordinates of our vertex is negative 2. So our vertex has coordinates 1, negative 2. So we have this graph here. So go ahead and draw that graph. Remember, we don't want it to come to a point or a corner at the vertex. We want it to be nice and rounded. This parabola opens upward where the vertex is a minimum. Okay. All right. So go ahead and flip the page. There are 4 problems here for you. Go ahead and try numbers 3, 4, 5, and 6 on your own. You can pause the video and then come back to check your work. All right, so go ahead and pause the video. All right, so here is number 3. Remember, to find the x-intercepts, we set y equal to 0. Zero product property gives us x-intercepts of negative 4, 0 and 2, 0. We plug in to find the vertex, we plug in those x-intercepts into our average equation to find an x-coordinate equal to negative 1, and then evaluating or solving for y when plugging in negative 1 for x. Don't forget those parentheses. We get a y-coordinate of negative 9. For number 4, we can see from this negative out in front that this is going to open downward. We're going to find our x-intercepts by setting the equation equal to 0, or setting y equal to 0, I should say, solving for x. We get 5, 0 and negative 1, 0. We take the average of the x-intercepts to get an x-coordinate of our vertex as 2, and then plugging in 2 for x, we solve for y. In the original equation, we get y equals 9. And here's the graph here. Number 5, we set y equal to 0 again, and solve for x. We get x-intercepts of negative 9 and negative 5. And then, taking the average of our x-intercepts, we find our vertex, x-coordinate of negative 7. And then plugging in negative 7, solving for y, our y-coordinate is negative 4. We get a graph that looks like this. And finally, for number 6, you might notice that this is a difference of squares, so this must factor 2x plus 1 and x minus 1, where the square root of 1 is 1. So we get the x-intercepts of 1 and negative 1. Finding the average, your x-coordinate of your vertex is 0, and then your y-coordinate, from plugging in 0 and for x, we get y is equal to negative 1. And you have this graph here. All right. So this has been graphing quadratic functions in standard form, finding x-intercepts, finding y-intercept, finding the vertex, I should say. We're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.